Okay, so our next speaker is Vishal Chowdhary. We worked together at Microsoft, and I gave a talk at GTAC when I worked for Microsoft, and now I don't. Just saying, you know, be careful. Be careful. Did you sign anything before you? Okay, never. I think you're okay. So he's going to talk. He was in the Azure group, and we were really keen to get someone from the Azure group at Microsoft at GTAC this year. But then he moved from Azure to MSR on us. But we love to talk too much to hold that against him. So Vishal's going to talk about how to hit a moving target in the cloud. Off you go. Thank you.
Thank you, James. So today's talk is about how to hit a moving target in the cloud. So first I want to clarify what's really moving and what's in the cloud. So we talk about test scenarios whereby it's not really clear what's the goal of testing. It seems that the goal of testing constantly moves. I take an example, a concrete example for machine translation, whereby the translation output always keeps on changing without any change in the user input. And to tie it all together, we will discuss as to, since the service is running in the cloud, how can we leverage that information to effectively test our service. So the talk is both about the cloudiness aspects or the fuzziness aspects of the tests, whereby it's not clear what you want to test, and the fact that the test is running in the cloud. So what we will go over today, what are the things that I expect you to get out of this talk? First is some approaches whereby, how do we test things whereby the output is not strictly defined? And what do you mean by that? Let's say all of us use smartphones and we try to, we are typing an email on our phone and it predicts a word. Sometimes it gets it right and sometimes it doesn't. So is that a bug or not? So how do you deal with those kind of things? The second is, we'll talk about some challenges about load testing a large-scale web service. This is not an in-depth load testing talk, but I'll try to go over some details. And I want to stress about that why it is important that we are very careful about why it's important that we are analyzing how users are actually using our service, and how can we make our testing better and also help set product priorities through that. And last is that how do you answer the question that are we done yet in these kind of problems, and taking that final steps. Most of the time we are opening bugs and we are making sure that the bugs get resolved and things like that. In this particular section of the talk, I want to challenge all of us that can we just go ahead and fix the bugs? Yes, we are testers, but can we go ahead and just fix the bugs? And what class of problems is something that we have tried it successfully? Finally, this is although the talk talks about machine translation, it's not intended to make you a machine translation guru. I don't expect you to go and write a machine translation engine after this talk. At the same time, it's not an in-depth load test talk. Okay, so what's the Microsoft Translation Service? It's a statistical machine translation service. What it means is it's going over millions of lines of parallel text. Think of a sentence in English, hello, how are you doing, versus a sentence in, let's say, Spanish, hola, ¿cómo estás, something. And it's trying to figure out what is the probabilistic model that this particular phrase in English means that particular phrase in French or Spanish, right? So it's building these what we call as translation models. Currently, our service supports 37 different languages, and what that means is you can translate from any of the 37 source language to any one of the 37 target languages. It's designed as a hosted service. It's running in the Microsoft cloud. We integrate with a bunch of Microsoft products like IE, Office. At the same time, we also have an API that supports popular formats, protocols like REST, JSON, SOAP, and which developers use and build kind of cool translator apps. So why is translation important? So I have this slide whereby as more and more of us are traveling over the globe, you kind of find these funny translations all over, and you want to make sure that the right message is getting across. But at the same time, this is a funny slide, but I want to give you a very concrete example whereby recently there was an unfortunate earthquake at Haiti. And what happens is, as a result of that, people around the globe, came into Haiti to help people out and said, like, okay, we want to help. And the first thing that, that they were kind of blocked with is language, that how I don't understand what this person is asking from me. And within a couple of weeks, we were able to build a machine translation system just for Haiti, Haitian Creole to English and any other language. And that helped, volunteers all over the world to serve the people better. So it has real, real life-saving implications other than these, comedy ones. So I kind of want to start, I would like to make the talk interactive. It's a large audience, so let's see, I'll try to repeat what you guys said. So for a moment, don't worry that we are at GTAC or a test conference or anything like that. And let's say there's a target that's moving, right? And you want to hit this target. What kind of things are coming into your mind? What aspects are you considering? What strategies would you use to hit this target? There's a moving target, yes. Okay.
One is just you like grab it, leave it fixed, and then hit it.
Okay. So a couple of suggestions. First is try to predict where the target is moving, and second is maybe try to control it or fix it, and then try to hit it. Any other suggestions?
Shoot faster.
Shoot faster. Okay, you shoot faster. Okay, than the target.
You try to move with it the same
Okay, so so there's it's moving with some speed and some velocity, right? Speed and direction, you try to move with it. So you make yourself constant with it. You kind of, although the target is moving, you're also moving the same way. So you both constant in the field of physics.
Use larger ammunition.
Okay, use a larger ammunition. Okay, so maybe, bombard it with, gazillions of arrows. Excellent idea, by the way. Nothing wrong with that. I'm sorry? Okay, so kind of learning, right? So a suggestion that just came up is you're kind of shooting one arrow, figuring out did you miss or not, and you're learning and then iteratively working on it. Get closer, okay? Okay, so any other suggestions? Okay. I'm sorry? Move with the target. Okay, so something that was suggested. Okay, so a lot of interesting suggestions. I would like all you guys to keep this in mind while we go over the talk and see how we can apply this, right? So let's look at a typical test case, right? What do we typically do? Let's say if we are testing a database engine or something like that. What we'll do is a test case will create the database and the table, insert. Let's say you're testing insert functionality. You'll insert 10 records. You'll query for those same set of 10 records. You'll make sure you get back the same thing or not, and you say, okay, the test passed or failed, right? Most of the time, that's kind of what the testing we do, where we know what's expected and we validate the actual with the expected, right? So let's look at the translation problem a bit. So there is this sentence in Hindi, and I'll just say it aloud. What it reads is, "ये कहने के कई तरीके हैं," and what that means in English is, there are multiple ways to say this, right? That's what the sentence translates to. If you think about this sentence, there are actually multiple ways to say this sentence, right? You can say, all of these are valid translation. You can say there are many ways to say this, there are a number of ways to say this. So now you have the problem that, okay, now there are multiple expected outcomes of the translation. And believe me, this is not the complete set, right? So you and me can come up with a set that's probably a subset of the entire possible correct translations. So that's one set of problems. So there's a larger set of expected. Let's look at another thing. What's constantly happening is, while we are shipping better code and better translation models, the output of the service keeps on changing. What that means is, although I'm giving the same input, the translation output varies, release over release, nothing that the test did. And finally, unfortunately, the translation output is never perfect. In this particular scenario, the sentence is ye kehne ke, and what ye, the word ye in Hindi translates to this. Turns out, the engine returns you that. Right? So instead of telling you there are multiple ways to say this, the translation output is there are multiple ways to say that. Do you understand what it's trying to say? Yes. Is it perfect? No. So how do you deal with testing a system like that? Now, before we go into testing, is this the only such problem? Is, maybe translation is unique. Maybe, we don't have to deal with anything else. Turns out it's not, right? There are actually a lot of similar problems out there. Look at web search, right? You're kind of getting a link of 10 results. They kind of change. Automatic speech, speech recognition made very popular by the iPhone recently, whereby you're trying, and my wife actually got an iPhone saying that I'm not conversational enough, so she needs somebody to talk to. Yeah, please don't laugh on me at least. Once again, automation, speech recognition, the recommendation engine that Amazon made very famous, and now they're all over the place, whereby it's suggesting things for you, and it's not the same, right? Look at maps, whereby somebody's telling you will reach there in 7 minutes. Okay, can you exactly say it's going to reach there in 7 minutes? In traffic, it might take you 12, but no, it took me 15 minutes today, so is it wrong? Is that a bug? What are we going to do about it? And last but not the least, weather, right? If you always look at the weather, it sometimes is right, sometimes is wrong. And what's the common thread that is kind of tying all these kind of applications are that you're learning from the past and trying to predict the future. And it is probabilistic. It is not deterministic whether you know exactly what's going to happen or not. And it can happen to something what, in case if you're testing a load balancer with 500 machines, it is going to make a best guess and send out a request to one of those machines. Is it going to be the same every time? No, because there are a lot of factors it is considering while making a decision like that. So there are these problems that happen throughout. Having seen this, any suggestions? How would you, test something like that? Let's say you have to test, now if I ask you that, hey, how do you test this translation output? Any such suggestion? Yes. Okay, so reverse translate, I know that's going to come up. Okay, so there was one suggestion about reverse translation. Anything else? You guys could do better. So, okay, so you translate from A to B and B to C, and maybe C whether C is correct or not. I'm sorry? Use people. Okay, so absolutely. Okay, use people. I'm sorry? Okay, so translate it back. Okay, so you have a fixed training set, and what are you exactly validating with the training set? You kind of, is it the translation output that you validate? Right,
so theoretically, some of the changes in your output are changes to your training set.
Yeah.
Maybe you're training on new data.
Yeah.
So if you're always training on the same data, any changes will be
Okay. Okay, so the idea suggested was that it's a machine learning system. There's a change in the algorithm, and there's a change in the training data. Make something constant. I'll take the last one.
Deploy it to production and see whether user likes the outcome.
Okay, excellent, right? So use users, deploy to production, and see what's happening. So I'll address some of these concerns, at least some of the points. The reverse translation doesn't work necessarily because if you have all learned probability, you'll know that P A given B is not the same as P B given A, right? So if it's exactly the same. The way the translation engine working is also taking a probabilistic measure, and the reverse direction doesn't hold true. So you'll actually notice that when you translate. There are a lot of websites which do interesting stuff. There was a thing about, hey, that maybe we can keep one of them constant, but turns out in the real life, both of them are changing all the time. And it's kind of hard to figure out when people are making a lot of tweaks to the engine, figuring out, shoving in a lot of tweaks to various algorithms. At the same time, you're getting larger and larger data. And the last suggestion that was suggested is very interesting is that, okay, hey, use people, right? Because they're that's the only way you do it. And, and they are the only people who will be able to give you the right outcome. So the way these things are done, at least the way we do it here is, instead of an exactness measure, I call this degree of closeness measure, right? So instead of saying that, okay, whether A translates to B, you say that, okay, these are the various correct outcomes of B. These are the various translations that you know about. Now let's see, and your translation engine produces an output. So let's see how close it is to the expected outcome. I take this slide from one of Stanford's NLP courses, whereby what it is doing is it's doing a word error rate. And in terms of speech recognition, when it is trying to identify the words that you have spoken, it looks at that, okay, how many words were different. So it's kind of an edit distance measure. So we kind of, we find out, so it's a degree of closeness measure. We test, a good suggestion there is we definitely now track this measure release over release and see whether we are actually improving or not. And we test it across various test sets. So what is very important is what are you testing it with, right? Just look at the word bit, B-I-T. The word bit to you and me means very simple, it's 1 or 0. But to my 16-month-old daughter, it's a different world. For her, bit means, okay, I know what bit means. So it's important that your test data is rich and varied enough so you can get a sense as to how good of a job you're doing. And finally, which is very important, is that do we trust numbers, right? Like if we do a measure like this, it will give you a number 0.6. Okay, so it will give you that when you ran your translation system across 1,000 sentences, the eventual outcome is 0.6. Now, okay, is it good, bad? I don't know. What is 0.6 related to what? So the interesting thing there is, I give an example of this sentence. Let's say I just say right now that I am not going to give all of you $1 million, right? And let's say you are definitely doing a very good job, but let's say somebody's translating it and drops the not. And suddenly you read it in your language that I am going to give everybody $1 million. So although I just changed a word, which is maybe 10% in the entire sentence, it completely changed the meaning of the sentence. So you want to rely on the numbers, but you don't want to only rely on them. You kind of want to do more. You want to make sure that humans are evaluating a system. And I was kind of debating, should I throw in some more technical details or not, but I think this is a good talk where I can. This is a good venue where I can. And mostly in most artificial intelligence kind of systems, what happens is that you are combining this notion of precision and recall and trying to come up with a measure. What that means is, precision means that, okay, ensure that you are only giving me good stuff, right? So for example, I can give you let's say you ask me to translate any sentence, I can give you all the words in the vocabulary, and I will always get everything right. You don't want to do that. And recall means that you want to at least give me all translations. I just don't want to give one specific word. Let's say there are 10 words in a sentence, and I know that this word definitely translates to that. I just give the output of that word, and I give you nothing else. So I don't want to be wrong. So that's kind of the idea. And there's some metrics like BLUE, what we use. BLUE is bilingual evaluation, and Meteor is another metrics that kind of combines these concepts and produces a number out of it. Having said that, so there was that initial issue of non-determinism, right? We didn't really know what to do with it. Things do change over releases. And how do we deal with it is that given a specific release, once you lock down the algorithms, the only things, and the algorithm and the data, then the translation output is guaranteed to be constant. And we kind of have a baseline, make sure that once things are locked down, they don't change. And if anything changes, it means that something is broken. That's how we deal with it. So finally, what I want to do is close down that, okay, what are the things that you can get out of this small section? Is that, okay, make sure when you face with a problem like this, you are substituting exactness. Instead of doing a double equals, you are kind of making a degree to closeness. There's a threshold that you're kind of evaluating against. If you have non-determinism, see you can break it into a sum of parts. And finally, we want to be data-driven, but numbers are a source of data. Humans are another source of data. Make sure you kind of get both. And finally, be careful about what you're testing with, right? So we have the service up and running. So we built this translation system. It's up and running in the cloud. Now let's see what happens, right? So this is how our service has been running in the cloud. This is data for the past 2 years, and we have had a 30%, 3,000%, 30x growth in traffic. And the various colors represent various sources of traffic. For example, one color might be Office, another color might be IE and Bing, and so on and so forth. So it's actually a very good position to be in, but also you kind of look, if you just pay a little bit careful attention, you notice dips whereby people are taking vacations and during July and December. So very interesting. At the same time, when something, let's say right now, we have a Facebook integration and suddenly you can imagine Facebook traffic coming into a service and there's a huge spike in that source. So there's interesting data points that you get out of it. So I want to kind of, so we are going to talk about load testing this service. So I just want to make sure, are most of us familiar with these terms or are they new to you guys? Okay, so it looks like 50%. I want to just at least maybe talk to a couple of them. So capacity is whereby you're trying to figure out what is the max your system can take before kind of falling apart. And spike is something that maybe your system can take 100 users a minute, and you suddenly spike it to maybe 500 users, and for a brief period of 10 minutes, and see what happens. So what's happening here when you're testing this load? When you look at this graph, things are changing all the time, right? Whatever your service was able to kind of get, was getting, let's say last month, it's getting some percentage more. The factors have changed a lot. The way the translation system works is, as you can imagine, if you give a short sentence to translate, it does less work, versus a longer sentence is going to take more work. There's some languages that are more complex than others, so they will actually, although you might send a 10-sentence, a 10-word English versus a 10-word maybe Spanish, things will actually take more time. So what is happening is the different things are changing all the time here. Your traffic is changing for each property. The percentage of languages, maybe it's 3% Spanish to English, 4% English to German. Those percentages just keep on changing, and what we are exactly translating, the kind of data also keeps on changing. You're running in the cloud, so the infrastructure changes, the network characteristic changes, machines go up and down. You might kind of add things. At the same time, your service is also changing. So everything is changing on you all the time. And now, how do you deal with that? So in the interest of time, I'm kind of not going to open this for questions. Maybe I'll try it for the last one. The way we deal with it is, we stepped back and we thought that, okay, what are the goals of load testing? What exactly are you trying to get out of it? The first is, which is first and foremost, is are you going to be able to sustain traffic in production? Are you going to hold up, or are you going to fall apart? That is most important. The second is, are you actually getting better release over release? Okay, so if everything remains the same, did you actually improve, right? I might actually throw in 10 machines and say that, oh, I can now do 10% more, but that that doesn't mean you actually got better. Maybe you actually degraded. And finally, when you get a spike, unfortunate incidents happen all the time, good or bad. For example, when the earthquake in Japan happened, we saw a huge spike in English to Japanese and Japanese to English translation, both into Japan and out of it. So now, can your service take care of that kind of load? And what we also do is we kind of tune our system to various languages at the same time. So the way we deal with this problem is there are these two concepts we are trying to do. Instead of running a set of load tests, we are running multiple sets of load tests, release over release. And this is not a comprehensive list. This is just to give you an idea, a flavor as to what are the most important things that are being done. So I'll kind of move on to this, to the details of it. What we are doing is, there is one test which I call it the same load test, or think of a test that has the same load profile. So here's where we are testing that, okay, let's say we support only these set of languages, and we are trying to build a test for it. So what we do is we look at the past, let's say 6 months worth of data, and we say that, okay, based on the last 6 months worth of data, this is kind of the percentage traffic distribution looks like. Then for each of the language pair, what we'll do is that, okay, what's the average sentence length that gets translated? And then for each of them, we'll say that, okay, average number of sentences per request, because a request can have multiple sentences. And then for every sentence, how many words, an average number. And what we do is, we kind of, as was suggested earlier, that we fix something. So this is what we fix here. We fix our test set, we fix our load test profile, and we test this release over release. And we kind of compare that, okay, if everything else remains the same, what that means is if our machines and our infrastructure, everything remains the same, do we get better or not? And we change this particular profile when, if any major infrastructure change happens or any major architecture change happens or things like that. And what we are looking for is things like throughput, error rate, and stuff like that. And but this doesn't guarantee that your service will hold in production, because maybe over the last month things change very dramatically. So what we are doing is, so this is what we have. And let's say we are adding a new language. So, and let's say it's Hindi, and we don't absolutely have no idea about what kind of percentage distribution that's going to take. So we kind of assume something. We make some things up based on our based on a good judgment from what we have seen in the past, and we adjust everything. What we are also doing at the same time is looking for all those languages. We are looking at what was their utilization the last month, and we are updating all the data values. And this test, along with the constant test, which tells us that are we getting better, this is the test that tells us that can we actually, if we roll this release out, what's the capacity that we can sustain, and will that hold up in production or not? I want to ask a simple question that, let's say we do all this testing in-house and we release it to production. Do you think that guarantees that we will never fail? How many of people think that that guarantees it will never fail? Okay, it's good that nobody thinks that way. So you're absolutely right, right? So we all know that production is the truth. Nothing, with your miniature test clusters, nothing can be done. A lot has been said about this. I'm not going to rehash, but the most important message I want everybody to get out is monitor. That is, make sure you are constantly looking as to what's happening to your live system. And what we are doing is we are kind of, looking at a large number of statistics and, kind of figuring things out here. And just some details about our log aggregation service. So this is a service that the test team owns in our team, and we are constantly mining the log data and kind of building and kind of trying to answer those questions for us. Some interesting questions that what is the average sentence length, what is the percentage distribution of traffic, and things like that. And things that we are very conscious that I think that worked well for us. First is make sure that you don't just have raw data for querying. What happens is that I will give a specific example. When the system just starts up, things are a little bit slower. So if you are searching for the slowest sentences, and if you have not filtered your data, some very innocuous ones will show up at the top. So you want to make sure that you're always filtering data. You want to make sure that in this world of less than 1 millisecond search, you want to figure out what's the best way that you can give this data to user immediately, and you are always refreshing the data. Challenges. Make sure what our system does is there is no PII information that we log. So if you are actually translating that my email is vishalc@microsoft.com to French, when we log that, we remove the email address from our system. So we kind of make sure there is no PII information that comes to us. We have challenges with data modeling. We are kind of writing gigabytes of data a day. You don't want to possibly analyze that. What kind of sampling techniques would you use? And finally, issues with log format and how to ensure that your tests aren't brittle to that. As a result of all that, we can answer all these questions. And the point I want to make across here is that these questions not only help testing, but also help address product priorities, right? So test is just one aspect, but the most important thing is that, okay, which language do we actually invest in next? And as a tester, I can say that, hey, this is the language that has been now getting a lot of traffic. You need to spend some more time improving the translation quality. So these are some of the things that we learned. So we have done all this. We have kind of done a load testing, and finally, we want to still make sure that are our translations of good quality or not. Now, it's a very unique problem, right? Like if you kind of look at translations, probably none of them is going to be exactly what you want. So do you open bugs? Like I can't possibly open a gazillion bugs. It will, people will go crazy and probably fire me tomorrow. Like, okay, this guy has probably nothing to do. At the same time, you want to improve translation quality. So how do you open bugs? How many do you open? And let's say when you're shipping something, when do you call it done? Because you will never get things right, all of them right. So these are some interesting problems that we face. And how do we deal with them? So the first class of tests I call is these general class, like this general medicines, whereby you can write thousands and thousands, whereby you're kind of constantly generating these tests. Just to give an idea about this, let's say there are these sentences, and in each of these sentences there are these 4th September 2010, and these are factoids, right? Like these are dates or numbers and things like that. What you can do is you can constantly generate newer tests and test your system against it. What this has helped us is find out patterns whereby the engine performs poorly in translation. For example, it might be when you have any number starting with 5, the engine completely buffs and gives you a random result. So that's one set of tests. Another set of tests, so that gives you some measure. Okay, you know what kind of are you doing a good job or not. But there is another set of interesting tests, right? So let's say there's this sentence, Mitt Romney moves the heads of Rick Perry in race. I kind of just got it from the news. Now, let's say you're translating this sentence to Spanish, you don't want to translate Mitt Romney to Rick Perry. Turns out those kind of things can happen. Why? Because since it's a probabilistic system, when the engine is learning these things, and since Mitt Romney and Rick Perry are in the same sentence, it doesn't really know, what does Mitt Romney translate to. So in these cases, what we do is we have specific tests, for countries, languages, important people, and make sure that we are translating them correctly. And we have some mechanisms to fix them, maybe not necessarily in code, but some hotfix mechanisms and things like that. Finally, are we done, right? So we are going to ship a new language. Can we ship it or not? Because at some other time we have to answer that question that, okay, are we ready? They will ask us, are we ready? Can we ship this? And it's a hard question here because there's no such prioritized list of sentences. These are P0 or P1 test cases, and we've executed all of them, pass, and let's ship. Right? There is no such thing like that. So what we do is we figure out, okay, we have test sets, we kind of set thresholds. Some thresholds we get by looking at competitors at university systems, figuring out that, okay, this is how they are, that's kind of the rate that they are doing translations, so probably this is good for us as well. We are looking at our various tests, our special tests, making sure that we are maybe maybe translating names correctly and things like that. And finally here, what we have seen is that, let's say we find a bug, right? Let's say we are not translating this sentence correctly, and it is very important. The only way to fix that maybe is to get good training data so that your engine learns the correct translation. And we said that, okay, is it any important for opening a bug for it? How will a bug help? A bug doesn't really help in this case. So what we ended up doing, the test team ended up doing is, writing an infrastructure, crowd-based, whereby we are farming these sentences out, getting back the good translations, and directly feeding into the engine. And in that way, we are kind of directly impacting the quality of translations, and by skipping the opening of bugs phase in this particular case. So that's kind of the end of the talk. And what I want to do is, kind of close on things that we chatted about before, about hitting this moving target. Somebody said, use a larger ammunition, lots of arrows. So you want to have lots of tests. Those are your generic tests. We didn't talk about that. Okay, what does it mean to hit this? Is there a bullseye? Do you have to hit that, or can you hit anywhere? What does it mean really to hit the target? In this case, there's no really exact answer. So there's some threshold. What is the cost of missing, right? Let's say you don't hit the target. For some things, maybe it's okay, but some things, like I'm not going to give you $1 million. It's not okay. So you have to kind of figure that out and build that into your testing, and things like spike and things like that. So, that's kind of what the talk is all about. Okay. Okay.
Hey Vishal, my name is Ilya. Thanks for, it was a beautiful talk. So one way of functional testing, like language translation systems, is obviously using systems from competitors to test oracles. Yeah. So have you ever done this? And so first issues I see is that first Google will keep banning you. Second, you're not always sure that Google actually translates correctly, right? But it's a system that's been around for like a couple of years, at least. So have you ever done this? What challenges have you faced? Was it useful or not?
So, so the question is that, okay, can you kind of compare, can you actually use an oracle? Can Google Translate be an oracle for Microsoft Translate? Turns out Google Translate is also a machine translation system, and even that is not perfect. So all our oracles are always human translators. So we always go back to the human translators, and kind of that's where we are getting our reference translations from when we are kind of getting these measures. But what happens is that in a lot of competitions, Microsoft, Google, a lot of university systems will kind of take part in that, and all of us will be evaluated as to what numbers we get. And we do get a sense as to how Google is doing, or how, for example, USC is doing for that particular thing.
One more question.
Yeah.
Okay. When you say oracles are human.
Hang on.
Yeah, that's an interesting topic for me. Have you tried, as test data, did you parse some dictionaries to get golden results?
Yeah. So I would love to. I think this is a very interesting question, and I would love to chat in detail about it later. But dictionaries, work for some very limited translations, for limited test cases.
They've got examples, not like the word translation. They've got examples of using words in real life.
Sorry?
Like they've got examples. Most dictionaries got examples of real-time word usage. Like they've got the whole phrase that contains a word,
yeah,
and the whole translated phrase.
Yeah.
So well, did it work?
Yeah, so what we have done is, if there are dictionaries like that, that those are very valuable, and those dictionaries actually come in, and we actually use them to learn, to build our models. So that's part of our training data. So you don't want to, this actually is a very important point. Since these machine learning systems, you have to be very careful with what you're testing. If there's something that you've already used up for training, you don't want to use the same for testing. Otherwise, you'll end up the same.
Well, you might try at least to do sanity checks.
Absolutely you do, but you don't want to kind of, that's not a good measure. You get very good results, mind-blowing results. Yeah.
Thank you.
Okay. Yes. Yeah, please. Sorry.
So my name is Nick Jasnicki from Orbitz.
Hi.
I had a question regarding how you guys were using load testing, specifically in the case where you carry out, spike tests to understand, what your system will do. How do you translate that into actionable knowledge, if there is a spike later on?
So let me see if I understood your question correctly. So I did a spike test, and how do I use that in real time? That how my system will perform? Is that
right?
Okay. So the way we do it is that we have, we say that, okay, in the past we have seen a spike, our system is tuned. Let me take a very specific example. Let's say our system is tuned for 10% English to Spanish traffic. And what we have seen is at spike scenarios, that number doubles, okay? Maybe it's 20%. What we will do is that although our system is tuned for that, can we handle that kind of a spike? Or if that kind of a spike happens, do we at least degrade gracefully? So those are the things that we are looking for, when we are doing spike testing, and having done that, we are again looking at production real-time system, saying that okay, that this is what we tried to simulate, and this is what happened. What are we doing better? Can we do better?
Hi, my name is Peener Patel. Actually, my question is how do you do the accuracy testing under load?
That's a very good question. So the question is, how do you do accuracy testing, if I understand correctly, testing for the translation quality under load? So what we try to do is, when we are doing our load tests, the bulk of our tests are doing some sanity translation checks. They are kind of testing that you don't get empty translations back. You don't get back things. You don't get back the same sentence and things like that. So we are not testing rigorously for almost all our load tests. Let's say you're running. I'm just taking a very simplistic example. Let's say I'm running 100 tests in parallel. I'm not doing that. But I have a slow running thread which is actually testing for translation quality. So I have this test that is actually, that gets this data, records the data. Obviously, it's not doing any quality measure at that point of time. And it's kind of, it logs all this data. And at the end of the test, there's another system that picks it up and kind of gets this measure and says that, OK, you kind of got the same measure what you did with and without load. OK, there was a question here. OK. Oh, sorry, my bad. Okay.
All right. So John Gomery from UTest. Question, you're using crowdsourcing to do basically close the loop on the quality of it.
Yes.
So how are you taking the context of the translation in what's being translated and for what purpose to feed back into your engine?
I'm sorry, I did not get the last part of the question.
The context. So the context of how this translation is going to be used, what type of product is being translated for, website purposes. So potentially, the language you're using, different words may be used in different contexts. And so the person in the crowd needs to understand how that word's supposed to be used in order for it to feed back to your
Absolutely. I think that's
so how do you handle that? I'm very curious.
Yeah, that's a very good question. So the way we do it is that I'll give you a specific example. Let's say we find a word whereby we can't translate a word. We get a word which we can't ever translate. What we do is we mine our logs. We get real sentences that users are trying to translate containing that word, and we present that entire sentence to our crowd community, and so that they are not only getting that word or the phrase, but the entire sentence, whereby they can figure out what is the context of translation and get back a good translation to us.
So you've talked a lot about kind of load performance spike testing. So one of the problems we've had is how do we translate our test systems that we can crash and do bad things to actually what our production real system out on the internet is actually able to handle? Because they're not necessarily going to be running on the same hardware or tuned the exact same.
Yes. So the perennial question of that your test systems are not the same as products, how do you deal with that? So the way we do it is that first of all, we realize that fact that yes, they are not the same. We try to do two things. First is we just try to crash our system, right? Like given this test bed, we just see that okay, can we generate crashes? What kind of scenarios can we generate crashes? And find out what bad things can we do to the system, and we fix and improve. On that. The second thing is we do realize that we can't, there are some scenarios that we cannot simulate in the test environment. And for that, we just are depending on the, once again, we sometimes test in production, but sometimes we are constantly monitoring in production and kind of looking at a crash that happened in production and fixing them. So we are doing a combination of things to kind of, fill in this gap.
So this will be the last question, and then we'll move on.
Okay, so I'll try to make this one a good one. Taking a basic example, let's assume you have a very static UI, and it just contains the word hello world, static text.
Yes.
And you're supporting 3 languages.
Yes.
Are you testing that static string with the 3 languages, or are you testing with 1 input and treating it as an equivalence class and assume if it works for 1, it's going to work for the other 2? Okay. So static text, 3 languages or X number of languages.
Yes.
Do you test in each language for that static text?
Yes, good question. So the answer is we test for each language. And I want to make sure that all of we can appreciate why. The way the translation, or any such system works is that if, let's say, English to French, does a good translation, that doesn't necessarily mean English to German will also be good, because it depends as to how you have built this engine, and you build this engine by by training it with various sources of data. And the data that you have used to train your English to French system might be amazingly good, and which you have used to train your English to German might not be that good. So although you might do a perfect job translating hello world from English to French, you might actually suck when you do English to German. Okay. Thank you guys.